Hello class, welcome back to Rocks and Weathery. This is part 3 of Rocks and Weathery, and we've taken a look at part 1, and we looked at the overview and the physical properties of rocks. Part 2, we look at how rocks are being formed. Now this part 3, we want to look at the breaking down of rocks. What process are rocks being broken down? What process initiates or contributes to the breakdown of rocks? And then we say that this process is known as weathering. So today we're going to look at weathering, but before we look at weathering, we say soil is composed of broken down rocks, and we've taken a look at that, and we've also seen that how it's possible for large hard rocks to be broken down in nature to form tiny grains and to make up what we call the soil. So we've taken a look at this. And today, we also say that we want to look at what the scientists have come up with. What they say, scientists use the word weathery to describe how the large solid lumps of rocks are broken down into smaller and smaller pieces by actions of wind, by actions of sunlight, by actions of ice, and by actions of water. So the factors that help the process of weathering are what we want to itemize. So today we'll be categorically looking at what we call the weathering. Weathering is the breaking down of rocks, of large lump sums of rocks into smaller tiny grains of rocks, and there are different processes by which this can happen. We have the physical process, we have the chemical process, and but before we talk about that, there are factors that facilitate this weathering process. Number one of those factors is the action of wind. The action of wind. Let's take a look at wind. I think I prefer this. The action of wind. Not only wind. Number two, the action of ice. Okay? The action of ice. Not only ice, wind and ice. The actions of sunlight. Okay, the continuous sunshine, the presence of sunlight on the rock, the heat from the sun hitting the rock day in, day out, the wind winding the rocks day in, day out, and the ice melting on the rock day in, day out. And which other factor is a good one? We mentioned wind, sunlight, ice, and the water. Another super factor is water. So these are four very inevitable factors that aid weathering, that helps rocks to break. Okay, wind, ice, sunlight, and water. These factors contribute to what the process by which the rock starts to break down, and that process is known as weathering. Now, so we're going to learn about two types of weathering. Like we said, okay, these are factors. The ones I have itemized now, they're called the factors that aid weathering. Factors affecting rocks, or factors that causes weathering. Okay, so I just say factors that causes weathering, or factors that aid the breakdown of rocks. And then let's take a look at types of weathering. We're going to take a look at two types of weathering today. Let's talk about types of weathering. Types of weathering. Types of weathering. Number one, we say physical weathering. Physical weathering. That's the first one. And we're going to describe it before we go to chemical weathering. There are two types. One is physical weathering, and the second one is the chemical weathering. Now let's quickly take a look at the physical weathering. Number one, let's itemize it. Number one, we say physical weathering. Physical. physical weathering. Okay, we mentioned and then we studied. Before we go to the number 2. The number 2 is chemical weathering, but let's first of all concentrate on this first one, which is physical weathering. Now, what is physical weathering? What do we mean by physical weathering? Okay, let's change our writing annotation. Okay, physical, or another name we can use for it is called mechanical weathering. You can say physical or mechanical. Okay, physical or mechanical weathering is a process that slowly breaks rocks into smaller pieces. Okay, this is a lump sum of rock, very huge one. Let's say, for example, this is a lump sum of rock. The process that ordinarily break this down into small pieces, into smaller pieces of rocks, into smaller pieces of rock. So the actions of sunlight, heated days, wind, ice, water, and after a long period of time, the rocks start to crack and break to smaller pieces. Okay, that's an example of a physical weathering. So for physical weathering to take place, the heat from the sun will hit the rocks, and then the rocks will start to expand. The heat from the sun will hit the rocks, and then the rocks will start to expand. The rock, let's say the sun is here. The heat from the sun hits the rock, and then the rocks start to expand. This is how the process starts. Then when rain falls, the water flow in it to create a lot of cracks. Water fall into it to create lots and lots of crack on the rocks. So when rain hits it, then when it rains, water gets into the small cracks in the rock. When it rains, water will get into small cracks. So you see sunlight, you see the factor of sunlight as it affects it. Then when it rains, water gets into the small cracks. Then at night, during the night time, cooling causes the rocks to contract again. During the day, the rocks will expand, contract, expand. So expansion is during the daytime when the heat from the sun hits the rock. During the night when it's cold, the rocks start to contract again. So small pieces break off. When it's contracting, crack, crack, small pieces will break off. In the day it expands, cracks start to form, because when you expand, crack will happen to the rocks. At night, within the presence of moonlight, everywhere will be cool, and the rocks will contract. So in the daytime, we say daytime, it expands because of the sunlight heat. Daytime, the rock will expand, okay, because of the heat from the sun. The heat from the sun. Why? Because of the heat from the sun. So I say heat from the sun. At night, heat from the sun. Or you can say because of sunlight. Because of sunlight. Whichever one is okay. Now, during the night, what happens? The rock will contract. The rock, because it's cold. Because it's what? It's cold. The rocks will contract. At night, the rocks will, let's write rocks. Let's write rocks. What happens at night? Here, rocks. What happens in the daytime? Okay, so at night it will contract. So small pieces will break off. It contract because of what? The moonlight. Okay? Cold. Because Because of moonlight. Let's say because, we just abbreviate because. Because of moonlight. Because of the moon. Okay. So that's what happens. Then you see when it rains, water goes, when it rains, what happens to the rock? Water goes into the rock. When it rains, water will go into the cracks. Water goes into the cracks of the rocks. And then when it freezes, when it's very cold, the ice expands in cracks. The ice will go into the cracks, and then they will expand inside the crack, pushing the rocks apart. So ice come into the rock when it's very cold, and then the ice go into the cracks, and then the ice, when they expand in the cracks, they will not cause more pieces of rocks to break away. So when this happens, we say weathering has taken place. We say weathering has taken place. We say weathering has taken place. Now, when the outer layer of the rock breaks off because of weathering, this is called exfoliation. 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 Exfoliation is the process whereby the outer layers of rock breaks off or break off because of weathering. The outer layer, when they break off because of weathering, then we say exfoliation. The process is known as exfoliation. The actions of water repeatedly freezes in the cracks and pushes the rocks to open, and then this is called the freeze-thaw process. The freeze-thaw process. The action of water, freeze-thaw, in the cracks, causing freezing and causing the rocks to break. This process is called the freeze-thaw process. The freeze-thaw process. Okay? So now in the hot, dry areas, the water in the cracks, in the rocks, will not freeze, right? This is only in the cold area. That in the cold area, like very cold time, like winter time, like country like Sweden, Denmark, Norway, Finland, Canada, part of United States, the northern part of United States, Russia, and some of these continental Asians or Central Asians. So like these countries, they have a lot of, even China, South Korea, North Korea. This country, they experience, Japan, they experience a lot of freezing and icing and cold and wintry and all of these things. So these rocks, during this period or this cold region, then the ice will expand in the rocks and cause the cracks to happen. And when the outer part of the rock breaks off, the process is called exfoliation. Now the freezing that is taking place in the rock causing cracks to happen is called the freeze-thaw process. Freeze-thaw process. We've talked about that. Now this is only in the cold region. What if we're in the hot area? The water that goes in does not freeze in the rock. The water that goes in cold region, they freeze in the rock. But in the hot regions of the world or in the hot countries, the water that goes into the cracks do not cause expansion, do not cause freezing the rock. The water that goes into the rock in the cracks do not cause freezing, right? So in the hot area, the water in the crack in rocks will not freeze. This area, the water evaporates. The water will find a way in the hot region, in the cracks, the water inside the cracks of the rocks, they will find a way to evaporate and leave salt crystal behind in the cracks. So water will evaporate in the hot area. Water will, H2O, let's use H2O for water. Water in the rocks, in the cracks of the rocks, will evaporate. will evaporate. The water in the cracks of the rock in the hot area will evaporate. It will not freeze. It will not freeze. It's only in the cold area that the water in the cracks of the rock will freeze. But in the hot regions of the world, water in the cracks of the rocks will not freeze, but will evaporate and leave salt crystals behind in the cracks. They will evaporate and leave what we call the salt crystals. Leave the salt crystals behind in the rock. Salt crystals. In hot countries like Australia, like Africa countries, like Middle East country, like the Saudi Arabia, Emirates, Qatar, all these countries in the Middle East, when the rocks cracks and water, it rains and water goes into the crack, the water will be super hot because of the heat from the sun that is hitting the rock. The rock is super hot. The rock is super hot, so the water becomes super hot and the water will evaporate. When the water evaporates, it leaves behind crystals of salt in the rocks. It will leave behind the crystals of salt behind the cracks of the rock. These salt crystals grow as more water fills the cracks and evaporate. It gets bigger and bigger. The crystal of rock gets bigger, grows bigger and bigger as more water enters the cracks and more water become heated up, become water vapor and evaporate from the cracks of the rocks. Now the growing crystals exert pressure on the rock and cause it to crack more further or cause it to break down. So the growing crystal, as this continues to happen, more water goes into the rock, the sunny day, the hot water becomes water vapor, evaporate from the rock. As this becomes bigger and bigger, leaving behind crystal of rock, the crystals of rock begins to grow bigger and bigger, and we begin to exert a lot of pressure on the rocks. We begin to exert a lot of pressure on the rocks, and this pressure will cause huge crack. This pressure can cause huge crack. Okay? Now let's move on. We say plants can also cause physical weathering, not only this kind of characterization we mentioned. The huge crack breaks the rocks into smaller pieces, and this is called weathering. This is called weathering. Now, plants can also cause physical weathering in rocks. Plant roots can grow into the cracks. You know that, right? So, apart from the water causing cracks, plant roots can grow into the cracks of rocks. Plant roots can grow into the cracks, and then by cause further pressure on the rocks, can grow into the cracks. Plant roots can grow into the cracks of the rock, and then they can cause more pressure. As the plant grows, the roots get thicker and bigger, right? As the plant gets bigger, the roots in the rocks get thicker and bigger, and then they start to exert huge pressure on the rock, and this can cause the rocks to break to smaller pieces. This will eventually cause the rocks to break to smaller pieces. Physical weathering is a slow process. It doesn't happen so fast. Except like you're looking at chemical weathering. Physical weathering is a very slow process. It doesn't happen so fast, okay? That's physical weathering for you. It's a slow process because it takes a lot of time. Okay, sun hits the rock every day, cause a little crack, water roll into the cracks of the rocks. In cold region, those cracks become ice. They form ice, and then this ice will expand and cause further breakdown. They exert pressure on the rocks and break down in cold region. In hot region, the water that roll into the little cracks of the rock, they do not become ice. They do not become ice. They get heated up and form water vapor, and this water vapor evaporates from the cracks, leaving behind crystals of salt, and then these crystals of salt gets bigger as this continue to happen by the day. These crystals of salt happens more and get more and more, bigger and bigger, and then thereby exerting a lot. The crystals of salt begin to exert a lot of pressure on the cracks in the rocks, and thereby breaking the rocks down into smaller pieces. So this is another way of physical weathering. Then we also say plants can cause physical weathering. How do plants do this? The roots of the plants can find their way to the cracks of the rocks. So as the plants grow bigger, the roots get thicker and bigger, and to a point where these roots become or form a very huge pressure on the rocks. And thereby, after a long period of time, these roots are able to cause the breakdown of the rocks into smaller pieces. So these are for physical weathering. And like we said, physical weathering takes a very long time. It doesn't happen so quickly. It takes a bit of time to happen. It doesn't happen so quickly. Is that okay? It takes years for this process to take place. So we say physical weathering is a slow process. Physical weathering is a slow process. It can take millions of years for large rocks to be weathered so much that they can be reduced to grains of sand. So that they can be reduced to grains of sand. It takes millions of years for large rocks to be broken down into small grains of sand that you see as soil. So it's not a very fast process, it's a slow process. The pieces of rocks that are broken by physical process or physical weathering and normally sharp-edged and angular in shape. They are sharp-edged and they are angular in shape. Now let's move on quickly to the next type, which is called number 2. Number 2 is called the chemical weathering. Number 2 is what? The chemical weathering. Number 2 is chemical weathering. So let's look at chemical weathering. What processes causes chemical weathering in rocks? And this process is faster than the physical process. We itemize the physical process. Now it's time to look at the chemical process. Chemical weathering. In chemical weathering, the minerals in the rocks are changed by the chemical reactions. Yes, there are minerals inside the rocks. We mentioned this. There are a lot of minerals inside the rocks. There will be some chemical reaction taking place as a result of the presence of minerals in the rocks. So we say the minerals in the rocks are changed by chemical reactions, and water and air are very important for chemical weathering to take place. So water and air are two big factors that contribute to chemical weathering. Air on one hand and water on the other hand, H2O. Water on the other hand is also a huge factor for chemical weathering to take place. Now let's begin to look at this step by step from the process. There are two main types of chemical weathering. There are two main types of chemical weathering. Chemical weathering itself is divided into two. The first one, let's call it A. The first one is called carbonation. The first one is called carbonation, and the second one is called oxidation. The first type or process that enable chemical weathering to take place is called carbonation. The second process is called oxidation. Now let's take a look at them one after the other. The first one is carbonation, and the second, the B part that causes chemical weathering to take place is called oxidation. Now we take a look at the first one, which is carbonation. What is carbonation, and how does carbonation cause chemical weathering to happen? Remember, weathering means breaking down of rock, the large lump sums of rocks into small tiny grains of pieces of sand, right? So, or tiny grains or tiny pieces of rocks. The breakdown of large lump sums of rocks into smaller pieces of rock is called weathering. Weathering is the breakdown of large lump sums of rock into tiny particles of rocks. Is that okay? Or grains of sand. That's called the weathering. And we say weathering, there are two types of process that enable weathering or that helps to break the rocks into it down. Number one is physical weathering, number two is chemical weathering. We've itemized, we've explained the physical weathering. Now it's time to look at the chemical weathering. We say in chemical weathering happens with two processes. The first process is called carbonation, the second process is called oxidation. Now let's take a look at carbonation. Now we're going to look at carbonation, this first one. So maybe we share it like this, and we describe carbonation on this left side, and we describe oxidation on the right side. Let's make it like in a tabular form. Carbonation on the left side and oxidation on the right side. Okay, let's begin to learn. You say the water in the rain combined with the carbon dioxide in the air to form the compound called the carbonic acid, right? The first process of carbonation is that the water in the rain, water is H2O, so I'm going to use a symbolic equation to itemize this. The water in the rain combined with the carbon dioxide in the air, so H2O plus CO2 we form what we call the carboxylic acid. We form what we call the carbonic acid. We form what we call a compound called the carbonic acid. Okay, the carbonic acid is H2CO3. H2CO3. So this is the first process of carbonation. The water in the air combines with the carbon dioxide. The water in the from the rain combines with the carbon dioxide in the air to form what we call the carbonic acid. Okay, this name is carbonic acid, H2CO3. Now, this weak acid can change the chemical composition of the rock by changing the mineral containing the calcium. So this one, number two, this acid will change the mineral composition of the rocks. This acid is no longer, what is inside the rocks now is no longer water. What has gone into the rock is no longer water, it's an acid. And this acid is capable of changing the mineral composition of the rocks. It's capable of changing the mineral composition of the rock. This acid is capable of changing the mineral composition of the rock. Is that okay? So we say this weak acid can change the chemical composition of the rock by changing the minerals containing calcium, sodium, and potassium into what we call the carbonate that are soluble in water. So it will change any mineral containing calcium, potassium, sodium, any mineral containing these elements into what we call the carbonate. Maybe like sodium carbonate, okay? Any mineral like, so if you have sodium plus this acid, you know, the acid goes into it. Now, instead of water going into the rock, it is this acid, carbonic acid, that has gone into the rock. Remember, the water in the air is mixed with the carbon dioxide in the air. The water from the rain mixed with the carbon dioxide gas in the air to form what we call the carbonic acid. And this is a weak acid. This weak acid, when it goes into the rock, there are some minerals like sodium. It will react with them to form sodium carbonate. It will react with them to form sodium carbonate. If it's potassium, it will become potassium carbonate. If it's calcium, it will become calcium carbonate. So to form sodium carbonate, not only sodium carbonate, to form calcium carbonate, not only calcium, potassium carbonate, okay, whatever element it has, okay, to form. If it's reacting with sodium, it becomes sodium carbonate. If it's reacting with them plus either plus water or plus hydrogen gas, okay, so it will react with the mineral containing calcium, sodium, and potassium into carbonates that are soluble in water. These compounds that are formed are soluble in water. These compounds that are formed, potassium carbonate, calcium carbonate, and sodium carbonate, they are all soluble in water. Is that okay? probably plus hydrogen. Okay, so each of them plus hydrogen. So this is what happens. And this compound that is formed, they are soluble in water. They are what? Soluble in water. They are soluble in water. Okay, now carbonation causes large caves to form in the limestone. So it will eat them up in the limestone area. This will start to form a large cave of these compounds in the limestone area. Especially if the rock is a limestone, then a large lump of this will be formed within this area. Limestone is made up of calcium carbonate. See? Calcium carbonate. So when this happens, you form, like if this happens, we get a lot of limestone. This one, calcium carbonate. So limestone is formed as a result of the presence of calcium carbonate. Limestone is made up of calcium carbonate, and this reacts with acid to form calcium hydrogen carbonate, which dissolves easily in water. The limestone rocks is slowly dissolved by the carbonic acid and carried away by groundwater. The limestone rock will be dissolved by the carbonic acid. The limestone rock, if you bring it with carbonic acid, this H2CO3, it will slowly dissolve it and take it away by groundwater. Okay? And slowly take it away by the groundwater. To dissolve it and take it away by groundwater. So carbonic acid can also attack harder rocks like granite, not only the limestone rocks. So anytime carbonic acid flow into a rock, it will eat up. First of all, it will react with any mineral it has to form calcium carbonate, sodium carbonate, and potassium carbonate. And then these are soluble in water. They will dissolve in water and begin to eat up the rocks and break down the rock. They will dissolve in water and eat up the rock and break down the rock. So we say carbonic acid not only attack limestone, they can also attack harder rocks such as the granite. When granite is weathered by carbonation, it becomes soft and it breaks down easily, producing grains of sand and clay whenever this happens. Is that okay? So when mosses, leeches, and algae grow on rocks, they can also produce acids that can dissolve the mineral in the rocks. So the carbonation is just a process by which this weak acid called carbonic acid. Carbonic acid comes from the rain reacting with carbon dioxide in the air. Okay, and this weak acid goes into the rock. The rock react with the mineral, dissolve them, melt them, and cause crack to happen in the rock and break down the rocks. This process is called carbonation. This process is called carbonation. It breaks the rocks down and creates a cave, like a cave. It breaks the rock down wherever it happens. It breaks it down. It washes away because it's a soluble substance now. It's washed away to the river. It's washed away and creates a cave, what we call cave, in the rock. So this process is chemical weathering. It's called chemical weathering. Now let's take a look at the oxidation process of weathering. Now in oxidation, in science, oxidation means adding oxygen to a compound. You have a compound, you add oxygen to it, then that is called oxidation. In weathering, the oxygen in the air and the oxygen in the air and the oxygen dissolved in water can react chemically with the surface of the rock to break the rock down, or to break down the original mineral inside the rock. The oxygen in the air can react with the oxygen that is dissolved in water. Okay, you know, the oxygen in the air can react with the oxygen that is inside the water. There's already in water, H2O, there's oxygen. So the oxygen in the air will react with the oxygen that is already inside the water to help to break down the mineral inside the rocks. Okay, so they will help to dissolve. Both the oxygen will dissolve in water and can react chemically with the surface of the rocks. So when this one will dissolve the oxygen in the air will dissolve in the water to have what we call a substance that is capable of breaking down the mineral inside the rock. So oxidation changes iron-rich minerals in the rock into rust. The iron-rich mineral in the rock will be changed to rust. The iron-rich mineral, iron, for example, iron-rich mineral will be changed to rust, right? Plus oxygen, 3 molecular atoms of oxygen. Now this one has already produced this. Okay, so this oxygen, the rich oxygen from the water will react with iron to form iron oxide. This is called rusting. This is called rusting. To cause the rust to rock, to rust. To cause the mineral in the iron in the rock to rust. Now you can often see that oxidation has taken place in rocks because they become brown, reddish brown or red. When you see the rock, they become you see a big hole in it. You also see that those surfaces become red or reddish brown or brown. So when you see this happens, then you know that oxidation has taken place because it caused the iron minerals in the rocks to rust. It caused the iron mineral to rust. Okay? When that happens, we say oxidation has taken place. Oxidation is faster in warm, moist climate than in cold climate. Oxidation of iron is faster in warm climate than in cold climate. So this is the weathering, how weathering takes place. This is how weathering do take place. Now let's take a look at what happens to weathered rock. When the rocks are now weathered, they're broken down, what will now happen to them? What happens to them? What happens to weathered rock? You know, the pieces of rock that have broken down, what happens to them? That's what we are asking. Weathered rock. The pieces, tiny pieces of rocks that have broken down from the big rock, they are called weathered rocks. What happens to weathered rocks? One of the things that can happen to them is that they can form sediment. They can form sediment and form sedimentary rocks. These weathered rocks, they will be washed away from the main big rocks. The tiny particles of weathered rocks, okay, will be washed away from the main rock to the riverside. Is that okay? Wash away into the rivers or into the oceans or into the sea. Wash away into the river. These tiny pieces of rocks, that are washed away into the rivers, right? Okay, or lakes, or sea, or oceans. Okay. Now these tiny pieces of rock that are washed away, they will begin to coagulate. They will begin to they wash into the river along the slope. They wash down to the river. When they get to the river, they start to combining with other debris in the river, like leaves, dry leaves in the water, and other sand, other pieces of rocks that be there washed. They begin to coagulate together, form small sediment. They begin to come together to form small sediment. Okay? They begin to come together to form different sediment. And this will eventually, different sediments, after a long time, will also react together to form a larger rock underneath the ocean to form what we call the sedimentary rock. Okay, to form what we call the sedimentary rocks. So some of the rocks actually be washed to the river. Some of the pieces of rocks are being washed to the river to form sediment, and this sediment, after a long period of time, come together to form a bigger rock called the sedimentary rock in the ocean. To form a bigger rocks called the sedimentary rocks in the ocean. To form a sedimentary rock in the ocean. And remember, these pieces of rocks, they are washed away by a process known as erosion. They are washed into the river, by a process known as erosion. Erosion is the washing away of materials, right? We say sand, clay, and rock particles that form when rocks is weathered are washed into the rivers, where they are carried along as sediment. They are carried along the river as sediment. River carries sediments as they flow. The faster the river is flowing, the more sediments it can carry, the more sediments it can move. The faster the river is flowing, the more sediments the river can carry. The sediment helps the rivers to wear away more rocks. The sediment helps the river to wear away more rocks. Erosion can also take place if wind, water, and ice have enough energy to move the weathered pieces of rock. Erosion can only take place if the wind, the water, the ice have enough energy to move the weathered pieces of rock. Now, the type of amounts of energy affect how quickly erosion can take place, and the size of particle that can be moved, and how much material can be eroded away, okay, depending on the energy of the water. If more energy is available, then the erosion will be more effective. If more energy is available, then erosion will be more and more. Okay, so with this, we've come to the end of this chapter. We've itemized rock. We looked at the pieces, the profiles of rock. We looked at rock, types of rocks. And before we looked at types of rock, we looked at the properties of rocks. And then we looked at types of rocks and how different rocks are being formed. And then today we looked at part 3. We looked at the process of breaking down rocks called the weathering. And the weathering, we divided it into two. We say we have the physical or mechanical weathering. The second one is the chemical weathering. The first one is physical and or mechanical weathering. The second one is what? The chemical weathering. We explain the physical weathering. We say it's just the sunlight hits and cause crack in rocks. When this crack happens in rock, rain falls, the water go inside. If it's in the cold region, this water will form ice in the rock. This ice will expand and get bigger and bigger and cause more crack and more pieces of rock, cause pressure on the rock and cause more pieces of rock to be broken from the rocks. And then we say if it's in the hot region, this water will not form ice, will not freeze to form ice. This water will evaporate, will become water vapor and evaporate. When they evaporate, they will leave behind what we call the salt crystals. These salt crystals, as more and more water goes into the cracks of the rock, the salt crystal grows and bigger. When this happens, we say the salt crystal will exert great amount of pressure on the rock and cause the rock to break to smaller pieces. We also say the actions of plants. The roots of the plants can go into the cracks of rocks, and when the plant is growing big, the root is also growing bigger. The roots get bigger and thicker to a point that they can cause huge crack and huge pressure on the rocks, thereby causing the rocks to break to smaller pieces. So these were on physical weathering. Now when we talked about chemical weathering, we talked about two phenomena. We said there are two types, carbonation and oxidation. In carbonation, we say that the water that is available in the small cracks of the rocks reacts with carbon dioxide in the air to form what we call the carbonic acid, H2CO3 acid. Although it's a weak acid, this acid inside the cracks of the rocks, it's able to react with the minerals in the rocks like sodium to become sodium carbonate and calcium to become calcium carbonate. These calcium carbonate, sodium carbonate, potassium carbonate, they are soluble in water. So they dissolve in water. When they dissolve in water inside the rock, thereby they start to melt all the mineral inside the rock, creating a very big lump, big cave inside the rocks. And because they dissolve into water, they be washed away to the river. They washed away. So the whole rock composition, inside it, there's a big hollow hole inside. Why? Because the mineral like calcium, like potassium, like sodium, they've reacted with the acid, with the weak acid, carbonic acid, to form what we call a soluble calcium carbonate. This calcium carbonate is washed away because it's soluble in water, is washed away, creating a cave inside inside the rocks. This is on carbonation. On oxidation, the oxygen in the air react with the oxygen inside water to form more atoms of oxygen, which will react with the iron in the minerals, or the mineral iron in the rocks, in the cracks of the rocks. The mineral iron in the rocks react with this oxygen to become oxidated. Now, oxidation causes rusting. So you see, when this happens, this is also soluble in water and is washed away, also creates a cave, and then you see that part that has taken place become reddish brown, or become brown, or become red, and so on and so forth. Then we also talked about the weathered rocks. What happens to them? The weathered rocks. What happens to the weathered rocks is that the weathered rocks actually begin to be washed away from the big rocks, washed down the steep slope. They're washed in pieces to the river. When they get to the river, together with clay, sand, and some plant debris, they form different sediments. These sediments, they're like new lumps, and they're carried away with the weight of the water. The fast-flowing water carries more of these sediments to a faraway location. And when they can get to a certain point, and this can form other sedimentary rock, which is what we have explained other sedimentary rock in the previous class. So with this, we've come to the end of our today's class. Okay, thank you for joining us.